Thank you all for coming here right before lunch. Everyone's hungry. Well, I'm going to do my best to get your mind off food and lunch for the next 50 minutes, talk about data mesh, a long overdue paradigm shift in data architecture. I know I did resist using the phrase paradigm shift. I couldn't resist. It ended up in the title. And it's one of the most used and abused phrases in our industry, right? Have you heard the phrase? Yeah, you have, I know. Do you know where it comes from, the origin of the phrase? Yes. Thank you very much. You're one of the very few people who actually know the origin of this. The other person who knows the origin of this, knew the origin of this, was our CTO, Rebecca Parsons. As you rightly said, in 1962, an American physicist and a historian of science, a philosopher of science, wrote this book, The Structure of Scientific Revolutions, and he coined the term paradigm shift in this very controversial book at the time. He made actually quite a few scientists upset. What he shared in his book was his observations about how science progresses through the history. What he basically said was, you know, scientists start their journey in terms of progressing science in this phase he called normal science, where essentially scientists are working based on the assumptions and theories of the existing paradigm. They're looking and doing observations to see what they expect to see, what they expect to prove. So not a whole lot of critical thinking is going on there. And you can imagine why scientists weren't so happy about this book. And after that, they start running into anomalies. They're making observations that don't quite fit the current norm. And that's when they go into the mode of, phase of crisis. They start doubting what they believe to be true, and they start thinking out of the box. And that's where the paradigm shift happens to the revolutionary science. Essentially, we're going from incremental improvements in the, whatever scientific field we are, to a completely new order. And an example of that, when scientists couldn't make sense of their observations in subatomic level, we had the paradigm shift from the Newtonian mechanics to quantum mechanics. What does that have anything to do with modern data architecture? I think we are in that crisis phase in the Kuhnian observation. The paradigms that we have adopted for 30, 40, 50 years about how to manage data doesn't really solve our problems today. The inconvenient truth is that companies are spending more and more on data. This is a survey, annual survey, New Vantage from top 1,000, the Fortune 1,000 companies. And they surveyed the leaders, and what they found out is that we're seeing an immense amount of increase in the pace of investment. That increase over the course of 1 year is budgets that are being spent between 50 million to 500 million and above, despite the fact that the leaders in those organizations seeing a downfall in their confidence as that money is actually giving results in measurable results. And even though there are pockets of innovation in terms of using data, and we don't have to go far, we just look around Silicon Valley when we see how digital natives are using data to change their businesses. But the incumbents and a lot of large organizations are failing to measuring themselves failing on any transformational measure. Are they using data to compete? Are they using analytics to change their business? Have they changed their culture? And while I don't want to, underestimate the amount of, work that goes into multifaceted change and transformation in an organization to actually change, use data to change the way we behave, changing our culture, changing our incentive structure, changing how we make decisions. But technology has a big part in it. And this is an architecture track, so that's where I'm going to focus. The current state is that, or the current accepted norm and paradigm, kind of has put this architectural landscape into these two different spheres with hardly much intersection. So we have the sphere of operational systems, right? That's where the microservices is happening. That's where the systems running the business are operating, your e-commerce, your retail, your supply chain. And really, we've seen an immense amount of improvements over the last decade in how we run our operational businesses, right? You just have to go to microservices track or DevOps track to see how much we have moved forward. And then on the other side of the organization, down the hall in the data department, we are dealing with the big data analytical architecture, which deals about, its purpose is, how can I optimize the business? How can I run the business better so I can upsell, cross-sell, personalize, experience of my customer, find the best route for my drivers, see the trends of my business, BI, analytics, ML, and that has a very different kind of architectural patterns and paradigms that we've accepted. So if you think about that sphere of our big data architecture, the three big generational technologies that I see in the wild working with a lot of clients start with data warehousing. Do you know when was the first writing and research and implementation of the data warehouse entered that industry? Any idea how many years ago? 40 years ago. Close, in the 70s. Late 60s, the first research papers and the data marts and implementation of that were in the 70s. So we had the data warehousing. We improved in 2010. We evolved to data lake, and now data lake on the cloud. So if you look at kind of the implementation or the existing paradigms of data warehousing, so the job of data warehousing has been always get the data from the operational systems, whether you run some sort of a job that goes into the guts of database and extract data, and before you use the data, try to model it into this model that's going to solve all the problems and world hunger, and we can do all sorts of analysis on it into, snowflake schemas or star schemas, and run a bunch of SQL-like queries over it so we can, create dashboards and visualizations, put a human behind the system, behind the analytical system to see what the heck is going on around our business. And the type of technologies that we see in that space, by the way, disclaimer, this is no endorsement of any of these technologies. This is just a random selection of things that you might see in the wild as a representative technologies to support data warehousing, right? You have the things like the cloud providers like the BigQuery or Power BI if you're on Azure that gives you the full stack to get the data into hundreds of tables and be able to query them in different ways. And then you have your kind of dashboard and analytics on top for your reporting. But the data warehousing, which we used for about 40 years, had been problematic at scale. This notion that we can get data from all different complex domains and put them in one model, thousands of tables and thousands of reports, then we can really use that in an agile and nimble way, has been an unfulfilled promise. So we improved, we evolved, and we said, don't worry about that whole modeling we talked about. Just get the data out of the operational systems, bring them to this big fat data lake in its original form, and don't do so much modeling. We deal with modeling afterwards. And then we have, we throw a few data scientists to swimming this data lake and figure out, what insights they can discover, and then we would model the data that for, downstream consumption in a fit-for-purpose way, whether it's like specific databases or a data warehouse down the line. And that has also been problematic at scale. I mean, the data department of running Hadoop clusters or other ways of, storing this big data hasn't been that responsive to the data scientists that need to use that data. And the type of technology that we see around here, the big storage, like the blob storage, because now we're talking about storing data in its native format. So we go with the plain blob storage. We will have tools for processing the data, Spark and so on, to join, to filter, to model it. And then we have orchestrators like Airflow and so on to orchestrate these jobs. A lot of clients that I work with, they still are not satisfied. They still don't get value at scale in a responsive way from data lake. So naturally, the answer to that is get the lake onto the cloud, right? Cloud providers are, speeding and competing in getting your data in the cloud and provide, services that are easier to manage, and they're doing a great job, but essentially they're following the same paradigm. This is an example from a sample solution, exemplar solution architecture from GCP. I can promise you, if you Google AWS or Azure, they pretty much look the same. So you've got on the left-hand side this idea that your operational systems, your old TP, everything through batch, through stream processing, throw it into the data lake, and the downstream model it into BigQuery or Bigtable if you want to be faster, and so on. And that looks wonderfully convincing, right? Wiring, fabulous technology to shove the data from left to right into this big cloud. But I want to step back for a minute, look at 50,000-foot view, the essential characteristics that are commonly shared across these different solutions that we've built, and get to the root cause of why we're not seeing the benefits that we need to see. So 50,000-foot view, I can promise you that I've seen so many enterprise data architectures that pretty much look like this. Obviously, they're drawn with more fancier diagrams rather than my squiggly hand drawing. But essentially, it's one big data platform, data lake, data warehouse, and its job is consuming data from hundreds of systems, the yellow-orange boxes that I drawn, across the organization or beyond the bounds of the organization, cleanse, process, serve, and then satisfy the needs of hundreds of consumer use cases, feed the BI reports, empower the data scientists, train the machine learning algorithms, and so on. And that, if you look at that technology, the solution architecture that I showed you, there is nowhere a discussion around the domains, around the data itself. We always talk about throw the data in one place. So this idea of this monolithic architecture, the idea of domains, the data itself is completely lost. The job of the architects in organization, when they find themselves with this big, kind of architecture, is to somehow break it down into its pieces so that they can assign different teams to implement the functionality between different boxes here. And this is one of the ways that companies at scale are trying to break down their architecture into smaller pieces. So they design ingestion services, so services that are getting the data out of the devices or operational systems. They have the processing team that is building the pipelines to process that, and there are teams that are working on the APIs or downstream databases to serve them. So that's pretty much, and I know I'm very much simplifying. Behind this is actually a labyrinth of data pipelines stitched together. But when you step back for a minute, what are we seeing here? We're seeing a layered architecture that is being, at top-level decomposition, it's being decomposed based on its technical capability, right? Serving, ingesting, and so on. The boundaries are the technical functionality. And if you tilt your head 90 degrees, you have seen this before, right? We have seen layered enterprise architecture where we had UI and business logics and databases underneath. And what was wrong with that? We moved from that to microservices, and why? Because the change doesn't happen. The change is not constrained to these boxes that we've drawn on the paper. The change happens orthogonally to these layers. If I want to introduce a new signal that I want to get from my device and now process it, if I want to introduce a new source or introduce a new model, I pretty much have to change all of these pieces, right? And that's a very frictionful process, the handover, the handshake, make sure the consistency happens across those layers. And if we come down a little bit more closer and look at the life of people who actually build this architecture and support them, what do we see? We see a group of people, siloed, data engineers, ML engineers, in the middle, stuck in between the world of operational systems that generate this data and the world of consumers that needs to consume the data, without any domain expertise, right? I really don't envy the life of data engineers I work with. And I'm hoping that we can change the life of these data engineers right here, right now, and from here on. What happens is the red people, the orange people, that are running the operational systems, they have no incentive to provide their data, their analytical data, right? Those historical snapshots, the events and reality and facts of the business to the rest of the organization in an easily consumable way. they are incentive to run their operational business, right? They're incentive to run that e-commerce system and build a database that is optimized to run that e-commerce system, right? On the other side, the purple folks, they are just hungry for the data. They need the data to train the machine learning, and they're frustrated because they constantly need to change it and modify it, and they're dependent on the data engineers in the middle. And the data engineers are kind of under a lot of pressure because they don't understand the data coming to them. They don't really have the domain expertise. They don't know how the data is being used. They've been essentially siloed based on the tools expertise. And yes, we are at that point of kind of evolution or the growth of technology that is still the data tooling is fairly niche space. Like knowing Spark and Scala and Airflow, it's a very niche space than generally software engineers. And we've seen these silos before, right? We saw the silo of DevOps, and we removed the wall. The wall came down, and we brought the folks together, and we created a completely new generation of engineers, called them SREs, and that was wonderful, wasn't it? With silos, we just have a very difficult and a process full of friction. A little, I guess, the stats just to show the skill set gap that we are facing and will continue to face with the wall in between is the stats that you can get from LinkedIn. Last time I searched was a few weeks back. I doubt things have changed much in 3 weeks. But essentially, if you look for jobs open today for the labeled data engineer, you find about 46,000 jobs open on LinkedIn. And if you look for people who are claiming to be data engineers on the platform, you see 37,000 folks. And I'm pretty sure all of them are in good jobs with good pay. So there's this huge gap in the skill set that we can't close with just siloing people. So essentially, this centralized monolithic paradigm, it was great maybe for a smaller scale. But the world we live in today is a world that data is ubiquitous. Every touch point, every action and interaction is generating data. And the business are driven to innovate, right? That cycle of innovation, test and learn and observe and change, that requires constant change to the data and modeling and remodeling. And this centralized system simply doesn't scale. A centralized monolithic system that has divided the work based on the technical operation implemented by a silo of folks. So going back to Thomas Kuhn's observation, we had the data warehouse and the lake on the cloud. What I've been doing for 40 and 50 years. We've been stuck in that normal science, right? We believe that the only way we get use of data is just getting into big, fat data lake or platform, get our arms around this so we can make sense of it, right? That this centralization was the dream of a CIOs of 30 years ago that, I have to get the data centralized because it's siloed in these databases that I can't get into. And that's the paradigm shift I'm hoping to introduce. So let's talk about data mesh. Hopefully so far I've kind of nudged you to question, right? Question the existing paradigm. So I'm going to go a bit top-down on that kind of, my mental model is fairly top-down, talk about the principles that drives this change, and then go deeper into some of the implementations, and hopefully leave you with a couple of next steps. So the principles of data mesh, that underpinning data mesh, are basically the ingredients of the best and most successful projects that we have had globally at ThoughtWorks. And it's applying the learnings of modern architecture that we've seen in the adjacent world of operational system and bring that to the data. The very first one is this decentralization. How can we apply domain-driven thinking and distributed architecture to data? How can we hide the complexity of that cell infrastructure that runs and operates the big data? And I don't want to trivialize that it is very hard to operate a Kafka cluster at scale. It is very difficult, to run your Spark cluster. So how can we abstract that away into self-serve infrastructure with platform thinking? And to avoid those silos of hard to find, hard to use, meaningless, not trustworthy data, how can we apply product thinking to really treat data as an asset? And finally, to have an harmonious and well-played ecosystem, what sort of governance we need to bring to the table? So I'm going to go into each of these ones by one by one, and hope to get a little better. right. Sorry, can you hear me? Okay, good. Domain-driven distributed architecture. Raise your of Eric Evans, DDD. About 10%. So go on Amazon, not right now, just after this, and get the book, or go to DDD, I think domain-driven website, fantastic. I can move it, but I think it's actually from here, and I don't know if it's battery or something else.
Is it?
You think? So essentially, what domain-driven design or domain-driven kind of distributed architecture, thank you, sure, introduces is this idea of breaking down kind of monolithic systems into pieces that are designed around domains. Sorry, I'm going to put this down, and next time I disconnect, I'll pick that up. Hopefully it will stay online. So picking the business domains that you have. So right now, what we discussed was breaking down, the way we're trying to break down these centralized monolithic data platforms around pipelines, right? The job of the different pipeline phases. Now we're applying a different kind of approach. We're saying, find the domains. So the examples I put up here are from health insurance, because that's where I am kind of waist deep right now with a client implementing their next generation data platform. When you think about the operational domains, a lot of organizations are already divided that way. So you've got in the healthcare domain, you have your claim systems that provides claims like pharmaceutical or medical claims that you're putting together. You might have your biomarkers, lab results, and so on. And then you see, so these are kind of the different domains that you see in this space, right? And if you think about these data domains as as a way to decompartmentalize your architecture, you often find either domains that are very much closer to the source, so where the data originates. In this example, for example, claims. You have the claim systems already either accepting or rejecting or processing different claims. So those systems are generating essentially, historical analytical data about claims. So there are domains that are closer to the facts of the business as they're getting generated. We're talking about immutable data. We're talking about historical data that is just going to be infinitely, forever and ever generated and stay there. And hardly, these sort of kind of data domains hardly change because the facts of the business don't change as much. Of course, there are industries where I get a new app and my app features changes, so the signals coming from that app constantly changes. But normally in bigger organizations, these are more kind of permanent and static data domains. And then you have domains that you are reifying. You're basically creating based on the need of your business. So these are aggregate data domains. In this example, I put in the example of patients' critical moments of intervention, which is a wonderful actually use case and a data set that the client that I'm working with right now is generating by aggregating a lot of information about the members' behavior, their demographic, the change of address, and apply machine learning to find out what are those moments that they, as an insurance provider, I need to reach out to my members and say, hey, you need to do something about your health. You just changed your address, you haven't seen a doctor for a while, you don't have a support network probably, you haven't picked a doctor or done your dental checkups, go and visit Dr. A or B. So creating these data sets, these are aggregate views, or the holy grail of healthcare data right now is longitudinal patient records. So aggregating all of your clinical visits and lab results into some sort of a time series data. So these are more consumer-oriented designed domains, and theoretically, we should be able to always regenerate this and recreate this from those native data products that we saw. Where do the pipelines go? Well, the pipelines still exist. Each of those data domains still need to ingest data from some upstream place, maybe just a service next door that is implementing the functionality or the operational systems. They still have to cleanse it and serve that data. But those pipelines becomes the second-class concern. They become the implementation details of these domain data sets or domain data products. And as we go towards the right-hand side, towards my right-hand side, I guess, your left-hand side, the orange and red blobs, we see more of the cleansing, more of the integrated testing to get accurate source of data out built into the pipelines. And as you go towards the consumer-facing and aggregate views, you see more of the modeling and transformations and joins and filters and so on. So in summary, with distributed domain-driven architecture, your first architectural partition becomes these domains and domains data products, which I go into details towards the end. I really hope that we don't use data pipeline as a first-class concern. Every time I ask one of our data engineers, well, can you draw your architecture? He just talks about pipelines. Pipelines are just layers, implementation details. What really matters is the data itself and the domain that it belongs to. There's this wonderful concept, architectural quantum, that Neil Ford and Rebecca Parsons, the co-authors of Evolutionary Architecture book, termed, which is the smallest piece of your architecture, unit of your architecture that has high cohesion and can be deployed independently of the rest. So we're moving to a world that our architectural quantum becomes this domain data products, essentially, that are immutable, that showing the snapshots and the history of the business, essentially. But how can we avoid this kind of, the problem that we have had to move from centralization, this problem of having these silos of databases and data stores now spread across these domains, and nobody knows what is going on and how do we get to them. So that's where kind of product thinking helps us. Are there any technical product owners or product owners in the room? Yeah, a few, 2, I think, if I counted. Welcome. So I think it's become quite actually common for us to think about the technical platforms that we build as products, because essentially the developers, the data scientists, they are the consumers and customers of those products, and we should treat them so. If you ask any data scientists today, they would tell you that they spend 80 to 90% of their time to actually find the data that they need and then make sense of it, and then cleanse it and model it to be able to use it. So why don't we apply product thinking to really delight the experience of that data scientist and remove that 80, 90% waste? So what does that mean? That means each of these domains that we talk about, like the claims domain, becomes the data, the historical analytical data for it, becomes a product. Yes, it has multiple shapes. It's a polyglot data set. You might have streams of claims for the users that prefer real-time or near real-time events about the claims. It might have buckets of batch or historical snapshots for data scientists because they love Parquet files and batch processing for 80% of their job. But for data to be an asset and be treated as such, I think there's some characteristic that each of these data products need to carry. First and foremost, they need to be discoverable. I mean, Chris mentioned in the previous talk that the world of data cataloging is on fire in a good way, and there are like tons of different applications, because data discoverability is the first and foremost characteristics of any healthy data platform. Once we discover the data, we need to be programmatically addressed so we get access to the data easily. If I can't trust, as a data scientist or data analyst, if I can't trust the data, I will not use it. And it's really interesting because in the world of APIs and microservices, running a microservice without announcing your uptime and having an SLO, it's crazy, right? You have to have an understanding of what your commitment to the rest of the organization is in terms of your SLOs. Why can't we apply the same thing to the data? If you have maybe real-time data with some missing events and some inconsistencies that's acceptable, you just got to explicitly announce that and explicitly support that for people to trust the data they're using. Good documentation, this description of the schema, where the owners are, anything that helps data scientists or data users to self-serve using your product. Interoperability. If I can't, now that I've distributed the data, if I can join the customer from the sales domain to the customer from the commerce domain, I really can't use these pieces of data. So that interoperability to unifying the IDs or some other field formats to allow that join and filter and correlation is another attribute of a data product. And finally, security. And it's such a privilege to talk after Chris here because I can just point to his talk. So he talked about RBAC and applying kind of access control in an automated way at every endpoint, at every data product. But these sort of things just don't happen out of good intention. We need to assign people with specific roles. So a particular role that we're defining where we're building this data products or data mesh is the data product owner. So someone whose job is care about the quality, the future, the life cycle of a particular domain's analytical data, and really evangelizes to the rest of the organization, come and see, I've got this wonderful data you can tap into and show how that can create value. So in summary, treating data, bringing the best practices of product development and product ownership to data. And if you're putting one of these cross-functional teams together with a data product owner, I will start with asking for one success criteria, one KPI to measure, and that is delighting the experience of the data users, the decreased lead time for someone to come and find that data, make sense of it, and use it. And that would be the only measure that I track first. And then, of course, the growth and the more number of users using it. And if you've been listening so far, you're probably wondering, what are you asking me? And this is the question that a lot of CIOs and people that actually spend the money ask me, is that you're telling us, distribute the data ownership, the analytical data ownership to different domains, create different teams, and then what happens with that, all that kind of technical complexity, the stack that needs to implement each of these pipelines, right? Each of these pipelines needs some sort of a data lake storage, need to have the storage account set up, need to have the clusters to run their jobs, probably they have some services. There's a lot of complexity that goes into that. And also decisions such as, you want to have your compute closer to your data, you want to have perhaps a consistent storage layer. So these sort of decisions, if we just distribute that, we create a lot of duplication, right? Duplicated effort, probably inconsistencies, and that's where, our experience in the operational world to creating infrastructure as a platform comes to play. We can apply the same thing here. So, capabilities like the data discovery, setting up the storage account, all of those kind of technical, the metal work that we have to do to spin up one of these data products can be pushed down to a self-serve infrastructure with a group of data, infrastructure engineers to support that. So just to give you a flavor of type of complexity that exists that needs to be abstracted away, here's just some list. Out of this list, if I had a magic wand and I could ask for one thing, was that unified, where is it? Unified data access control. So right now, it's actually a nightmare to set up a unified policy-based access control to different mediums of storage, right? If you're providing access control to your buckets, or if you're on Azure ADLS versus your Kafka versus your relational database, every one of them has a proprietary way of supporting that, and there are technologies that are kind of coming to play to support that, extensions, future extensions to OPA, Open Policy Agent, and so on. So there's a lot of complexity goes into that. In summary, the platform thinking, or data infrastructure, self-serve data infrastructure, is set up to build all of the domain agnostic complexity to support data products. And if I set up one of these teams, and we often, very early on in the projects, we set up a data infrastructure team. The ask for them and the metrics they get measured by is the amount of time that it takes for a data product team to spin up a new product. So how much complexity they can remove from the job of those data engineers or the data product developers, so that it takes a very little amount of time to extract, to get data from one domain and provide it in a polyglot form to the rest of the organization. And that's their measure of success. Anybody who's worked on distributed systems know that without interoperability, a distributed system would just fall on its face. If you think about microservices and the success of APIs, we had the one thing that we all agreed on. We had HTTP and REST. And we pretty much all agreed that's a good idea. Let's just start getting these services talk to each other based on some standardization. And that was the key to the revolution of APIs. And we need something similar here when we talk about this kind of independent data products that providing data from different domains so that that data can be correlated, joined, and processed or aggregated. So formulating what we are trying to do is creating this nexus of kind of folks that are coming from different domains and formulating a federated governance team to decide what are those standardization we want to apply. And of course, there are always going to be one or two data products that are very unique, but most of the time you can agree upon a few standards. The areas that we are standardizing, first and foremost, is how each data product describe itself so that it can be self-discovered. So the APIs to describe a data product, which I will share with you in a minute, to find and describe a data product and discover it. The other area that we very early on work on is this federated identity management. In the world of kind of domain-driven design, there are often entities that cross boundaries of domains, like customer is one of them, member is one of them, and every domain has its own way of identity, these what we call polysemes. So there are ways to build kind of inference services in a user machine learning to identify these, the identity of the customer across the different domains that has a subset of attributes and generate a global ID so that now I can, as part of publishing a data product out of my domain, I can do internally a transformation to a globally identifiable customer ID so that my data product is now consistent in some ways with the other data products that have the notion of customer in them. And most importantly, we try to really automate all of the governance capabilities, or capabilities that are related to the governance. So the federated ID system management is one of them. Access control is another one. How can we really abstract away the policy enforcement and policy configuration for accessing polyglot data into the infrastructure? So let's bring it together. What is data mesh? If I can say that with one breath in one sentence. A decentralized architecture where your unit of architecture is a domain-driven data set that is treated as a product owned by domains or teams that most intimately know that data. Either they're creating it or they're consuming and resharing it. And we allocated specific roles that have the accountability and the responsibility to provide that data as a product, abstracting away complexity into infrastructure layer, a self-serve infrastructure layer, so that we can create these products much more easily. All right, ready for a real-world example? Okay, so this is a real-world example from the health insurance domain. So on the top corner, we see a domain, we call it call center claims. So it happens that these organizations have been running for 50 years, and they usually have some sort of a legacy system. So this is the online call center application that is a legacy system. The owners and writers of it are no longer with us. So we had no other option but running some change data capture as an input into a data product that we call online call center that's running within the domain of online call center. It's not something different. And what this data product does is provide the call center's claims daily snapshots, because that's the best representation of the data from that domain, from the state of that legacy. In the other corner of the organization, we have this brand new microservices handling the online claims information, right? You have a microservice, it's new, the developers are sharp, and they're constantly changing it. So they're providing the claims events as a stream of events. So we bundle a data product with that domain, within that domain called online claims data domain, that now it gets data from the event stream for the claims and provides two, polyglot data output, essentially. One is similarly the events that it's getting. It does a bit of transformation. It unifies the IDs and a few different field formats that we agreed upon. And also it provides for data scientists, it provides Parquet files in some sort of a data lake storage. But a lot of the downstream organizations, they don't want to deal with duality of whether it's online or whether it's data center. So we created a new data product. We called it just the claims data product. And it consumes from upstream data products ports from the online and from the call center and aggregate that together as one unified stream. And obviously, it provides a stream. It wants to still maintain the real-timeness of the online. So the events that it gets generated are actually for the legacy system is kind of synthesized from the daily changes, so they're not as frequent. But we also have the snapshots. So we have now the claims domain. And we can play this game forever and ever. So let's continue. You've got the claims. The other side of the organization, you've got the members, people who deal with registration of the new members, change of their address, change of their marital status, and so on. And they happen to provide member information right now as buckets of kind of file-based information. And we had this wonderful, ambitious plan to use machine learning to aggregate information from claims, from members, and a bunch of other upstream data products, and create a new data product that can provide to the staff information about members that need some sort of an intervention for a better health, essentially less claims and less cost for the insurance company. And that downstream data product, the member interventions data product, runs actually a machine learning model as part of its pipeline. So these are, you saw on the previous diagram, kind of these ones are more going back, native and closer to source data product. And as we move towards this, you move towards kind of aggregated and new models and consumer-oriented. One of the questions or puzzles for a lot of the new clients is what is this data product? What does it look like? We can't really understand what it is because the mental model, we're kind of like inverting the mental model, right? The mental model has always been, upstream into the lake, and then lake converted into kind of downstream data systems is very much a pipeline model. It looks like this. Looks like a little bug. This is your unit of architecture. And I have to say, this is the first incarnation of this, right? We've been building this now for a year, but it's hopefully you will take it away, you make it your own, make your own bug, and build a different model. But this is what we're building. So every data product that I just showed, like the claims, online claims, and so on, it has a bunch of input data ports that gets configured to consume data from upstream streams or file dumps, or CDC, or APIs. They can be, depending on how they're consuming the data from the upstream systems or upstream data products. They have a bunch of polyglot output data ports. Again, it could be streams. This is what the data that they're serving to the rest of the organization. It could be files. It could be SQL kind of query interfaces. It could be APIs. It could be whatever makes sense for that domain as a representative of its data. There are two other kind of lollipops here, what we call control ports. Essentially, every data product is responsible for two other things rather than just consuming data and providing data. And the first one is be able to describe itself. So all of the lineage, metadata information, address of these ports, the output ports that people care about, schemas, everything comes from this endpoint. And if there is a centralized discovery tool, they would call this endpoint to get the most, latest information. And because of the GDPR or CCPA or, some of the audit requirements that usually the governance teams have in the organization, we provide also an audit port. If you think about on-prem to cloud movement, that happens if your upstream happens to be on-prem and downstream happens to be on cloud, the conversion from, the copying from on-prem and cloud happens in the ports configuration. And if you look inside, you will see a data pipeline, a bunch of data pipelines, in fact, that they are really copying the data around and transforming it and snapshotting it or whatever they need to do to provide it downstream. And we also deploy a bunch of services or sidecars with each of these units to implement the APIs that I just talked about, the audit API or the self-description API. As you can see, this is quite a hairy little bug. In microservices world, it's wonderful, like you build a Docker image and inside it, it has all the complexity of implementing its behavior. Here, every CI/CD pipeline, which is a CI/CD pipeline independent for every data product, actually deploy a bunch of different things. So for example, on Azure, on our input data ports are usually Azure Data Factory, which is like the data connectors to get the data in. The pipelines are as Databricks Spark jobs. The storage is ADLS. There's a whole bunch of things that need to be configured together as a data product. Apologies for people in the back of the room. Gwen will share the slides, but essentially, discoverability is a first-class concern. You can get hidden endpoint, RESTful endpoint to get the general description of each of these data products. You can hit an endpoint to get the the schemas for each of these output ports that you care about, and documentation and so on. Where's the lake? Where's the data warehouse? Where is it? Well, it's not really on this diagram. So I think the data warehouse as a concept, like having BigQuery for, if your big table for running fast SQL queries, it can be a node on the mesh. The lake as a storage, you can still have a consistent kind of storage underneath all of these data products, but they're not a centralized piece of architecture any longer. The paradigm shift we're talking about is from centralized ownership to decentralized ownership of the data, from monolithic architecture to distributed architecture, to really thinking about pipelines as a first-class concern, to domain data as a first-class concern. Data being a byproduct of what we do, as an exhaust of an existing system, to be a product that we serve. And we do that through, instead of having siloed data engineers and ML engineers, we'll have cross-functional teams with data ownership, accountability, and responsibility. And with every paradigm shift, needs to be a language shift and a language change. And here are a few tips as how we can use a different language in our everyday conversation to change the way we imagine data, to change the way we imagine data as this big divide between operational systems to analytical systems, to as one piece of architecture that is fabric of our organizations. And hopefully, now I've kind of nudged you to question the status quo, to question the paradigm of 50-year paradigm of centralized data architecture, and get started implementing this decentralized one. This is a blog post that, to be honest, I got really frustrated and angry, and I wrote in a week. So I hope it helps. If you have any other questions, feel free to reach out. I have also my colleagues here, Scott Davis down here, who also gave a talk, and Jared somewhere here. We are also hiring, so if you want to implement and spearhead the database paradigm shift, feel free to come and talk to us. Thank you.